Hello students. This is a video recording to show you a particular figure, which is the figure of a three-dimensional Cobb Douglas utility function. I meant to show this figure on a screen during class, and unfortunately I had technical difficulties. So I thought that I could just show you this from the comfort of my office, and you can receive it via email. What you are seeing here is a figure that is being a figure of a particular mathematical function, which is the Cobb Douglas production function. You can see the production function written up here. The production function is z equals to x to the 1/3, y to the 2/3. So here the z the z axis is this vertical one, and in class we talk about the utility. So think of z as the utility. This measures the number of utils. X and y are the two goods, so good x and good y. So you can see how this function, this utility function, changes as you go from the origin, which is where you have 0 and 0, and you increase here the x good, and here you increase the y good, and you can see that it looks like a hill. Now this function actually has another component which is on the bottom of it. Just ignore that. That's in the negative space, and we of course are only operating with positive numbers, positive goods, bundles that are made of positive goods. What you can see very clearly is the shape of the mountain, right? As that it's essentially a hill that goes up as good x and y increase, and that's the view, the three-dimensional view. Now I could take this y-axis and point it up. If I point out up the z-axis, sorry, so the z-axis, the utility, is looking straight at you. What you really see are these contour lines. Now these are contour lines, and the contour lines are measurements of the contour. For each of these lines gives you the exact same amount of z. In which case, in the case as we've seen in class, each line here would give you the same amount of u of utility. Okay, so in difference curves, you can see that they get closer on this side. They're closer on this side. They're not as so close in the middle. But you can also notice that they never cross, right? They're never crossing. They're always parallel. If you were to look on in this other way, with this other view, then, okay, let me see, yes. So then what you're really seeing here is a view of, you're looking at this function in profile. So here I'm holding what I just clicked here, the white sheet here. I'm holding good y constant at y equals to 4. And here the contour shows you how the utility function changes as x, which is on this axis, changes. It goes from 0 to positive numbers. So you can see that it's increasing really fast initially, and then it slowly starts to, it continues to increase, but at a diminishing rate. Okay, so this is the view that, this profile is what I've graphed in class at the end of the class. Okay, and this is what we're going to pick up on Monday. I could do the same thing, so I could fix x at a value equals to 3, and then look at the function from this angle. Okay, so there it is. Okay, now I'm looking from the other side. Here the x function we don't really see it, and what we see in the profile is the y function, how the utility changes as y goes up. Okay, so that's it. This is just a quick video for you to appreciate how these utility functions look like in real life. And we will be, in class, we'll be working with a two-dimensional object. Again, either this position or this position, and but always keep in mind that we're going to have a three-dimensional object. Okay.